Then storage or frame grabbers. If you are having video data, then frame grabbers are required or storages are required. So hardware and software again is there. Initial operations like sampling and quantization and encoding. Later on, file format, particular file format or compression can be given. Next part, very importantly, there is a noise source, light source. So you can arrange structured light. You can arrange structured light. Various types of lighting arrangements are there that can be worked out. Then various algorithms like processing the image. Just a minute. So image processing techniques include like file format compressions, then data reduction, digital conversion, thresholding, segmentation, boundary detection, object recognition, and template matching. So our basic setup includes a robot inside a cage. So you can see in industry you are having cages like this, wherein actual manipulator is assembled and it is working inside a dedicated part. All of us always think about only this setup and design of this thing. There are allied systems over here like electrical systems which will be providing the power, safety things like interlockings, earthing, or no man's entry whenever it is operating. So many things are related to that. They are also here. These are some other examples, like this is how smart pad teach pendant is there. This is what Kuka manipulator, so robot controller and its actual leads how it is connected. Okay, now we turn to actual engineering behind this camera and robotics. All of you know now robot has got structure. Robot had got its own coordinate system. So the movement of the gripper or a tool with reference to the base. I'll not go in details about robot structure. So you are having tool and this is what base. So this movement or these coordinates are with reference to this reference frame. So this is what we call as reference frame, wherein base is generally fixed and then each of this joint operates, that is moves, and each movement creates coordinate, and all this measurement of movement or control of the movement is with reference to the basic frame called as reference frame. So each of this joint, each of this link contributes to the final motion of the tool. Please check concept. When we move this tool on a particular object or job, then each of the link, each of the joint is now contributing for that movement. So whatever target movement of the tool, that is with reference to reference frame, which is treated as F0, and F1 will be the tool. You might be knowing the terms like tool vector. There is a derivation in a kinematics of the robotics. You must have learned that. So these two positions are treated as a control things. Now this is part of robotics. So we have object frame, we have tool frame, and we have reference frame. Whenever object tool frame is configured exactly on object frame, that means we say that gripper is on job or on object, or tool is on object. So this is what our target vector. So this is what our target frame. So your tool or actual gripper is moving in 3D space. That is what XYZ. And it is always trying to map the object frame. To do this, all these movements of the joints and links must be done, and they are with reference to reference frame. This is what said as frame mapping. Now, if you derived that tool vector, there were in that tool vector, there was a space in that matrix that is for camera and which was placed in feedback. So now normal robot operation is now enabled with camera, and camera act as a feedback. So now one more frame is there. So this camera frame is always mapped to the object. Now robot has to move with respect to reference frame. Robot has to move with respect to reference frame, its object frame to the target, or its tool frame to the object, and your tool frame must be mapped with object, and at the same time camera frame must be mapped to that. This is what said as frame calibration. That means every now and then camera will show me exact region of the interest in the image or exact reference part of the object. And my ultimate goal is that every time my tool must go, of course whenever required, when it is programmed, it should go to the object frame. So when tool, object and camera three are mapped, that means we are we are in the workspace. We are in the workspace or work envelope. If you recall some of the terms like work envelope, right, where actually robot tool or gripper is working, that trajectory or that particular area is known as work envelope. So when this tool enters in the object frame and it can be visualized by camera, then we say that all three are mapped. So whenever bot is working, camera must capture it. Camera must capture it. So look at here, this is what overall movement, and every now and then along with tool, camera is also mapped. Again, for different tasks, this cannot be always in object frame. For example, picking and placing. So it is picked up. Right now it is in camera. Now it is placing. So it will not be in camera. So with reference to reference frame, first of all, it will align or start for picking operation. So all joints and links will give required motion and movement so that gripper can go to the object and grip it. Now object is gripped, so it will be going to different position. So this camera may not work. There will be separate camera where place position is there. So this is picking environment, placing environment camera. Now this will go and now it will move to the place workspace. So at that time, tool, object, all these enter in the camera frame of place operation. Again it has to come back, and again it has to realign all the three things. This is how real operation goes. This is what said as frame calibration. Now robot is having communication cable, controller. This is another type of robot what we are showing, and there is a camera every time. Now let us enter in some deep concepts of frame calibrations. Now up till now we say that the tool is moved with reference to reference frame, that is base. It entered in the object, and now camera is aligned. All three are aligned. So we have to ensure that whatever captured part is there, that is correct to the object view. Otherwise, it is useless. Another part, we are capturing that image not only just for seeing, we have to perform measurements also. So to perform these measurements, you can provide calibration grid. Calibration grids can be internal or external. External calibration grids that places this grid on the camera lens or view, or software generated calibration grids are there. So once you generate grid, so your image will be placed on this. This is very essential because we need coordinate system on image to perform the measurements and later programming operations. So camera frame calibration further says that this is camera view which is aligned now to the tool and whatever it is looking at object. So right now here you are having tool and object together. Now how you are projecting, because this view is now exported to user. So this is said as image plane. Right now it is 2D image plane, and then later on it will be projected on grid. See, now this is what camera look from camera side. Right now you have got your tool and you have got your object in the same frame. Now camera is capturing. So this is what camera frame. Three are aligned. Now what will happen? User will see this image plane. This is what user view. And now see that this point of is of the interest. Then it must be measured. So it is projected on calibration grid. And then user can see where exactly is that point. This is what said as frame calibration. So this point is actually here inside the scene and it had got that particular place. Now in setting up camera for such task, many times indigenous softwares are there made by robotic manufacturers, and there are camera alignments. So when we purchase camera enabled grippers or robots manipulators, software comes with it, and then we have to perform various operations or make programming and go for further tasks. Now how to align and where will be the camera is the next part. So actually I have shown here only two conditions: inclined space and horizontal space. Actually in industrial scenario this can change. It will not be such a royal thing that the job lies on horizontal and plane surface. It may not be. It can have various types of surfaces, orientations where our manipulator is working. So generally we have to see or place a camera such that this object view is not interrupted, and it should see clearly the object, and that angle of camera rays or camera view with object is required to be 90 degrees. At the same time, tool must enter in ZX frame, that is user frame, in 90 degrees. This is how it happens. But this is what again theoretical part, right? Many times it depends on application, how gripper has to approach. Accordingly, view must be cleared every time. Then in software you can see whatever captured, that view is there, and then captured image is processed by different image processing applications. That is what vision software, or there are different tools for that, and you can align this and program whatever required things. At the end there will be perception, or there will be resultant operation from image, and further stage will be continued. Let us talk about some problems over here. First of all, a camera view is always angular. Now look from the distance perspective. Even look at you, how you visualize the things. Our eyes are like car headlights, and range is a concept that means it is always goes on increasing. Nearer the object, bigger will be the object, and as distance is increased, object becomes smaller. This is natural physical effect. Now you will ask me, sir, why we are discussing here? Because this can create problems in the robotic view. So depending on the camera distance, there will be offset, that is what additional distance. There will be change in the view of the object. Captured image will be small if camera is too away. Captured image will be too large if camera is nearer. So this is fixed frame offset, because camera is now fixed and you are looking from camera perspective towards the object. You are looking from camera perspective towards the object. Similarly, other side is there, that is tool offset. Now tool is at gripper and you are looking from tool perspective towards the camera. Still this position matters. Where is the camera? So one is because of fixed frame offset, because camera is in fixed position. In other case, camera is fixed and tool is moving, but you are looking from tool point of view. In both cases, because of the position, there will be offset, that is what increase dimensions or change in dimensions. Same object, we will get different shape of the images. Many times normalizations or many other program objectives can be done over here. This is what all discuss is written in these concepts: fixed frame aspect and the tool offset. Now another twist in the problem is that earlier part, where is the camera, that was the thing, and where is the object. And if object is nearer, we'll get bigger picture. If object is away, we'll get smaller picture. That was the problem. In second case now, where is the camera? Camera is whether fixed on a particular stand or particular position, then this is said as fixed camera. And in other case, some of the cases, camera is fixed on the manipulator, so robot mounted camera. These are next two variations.